Check one. Check one. Check one. Right. Good morning, everybody. Before we start, just confirm me whether the audio video is all the DOs perfect. I'll allow you all to unmute. I'll open the group also.
Yes, sir, all clear.
All clear. I'll open the group. Waited for some time today to start because all of you should join. I'll open the grade 10 group. Sorry, groups are open. All clear. In the description, I added the tutor. Plus, in the group also, I was regularly adding. Hydrostatics. Is you can't finish it in 1 in 2.5 hours. You can't. Today, do the lesson. Tomorrow also we'll use the same link. Check now. Otherwise, it play. Oh, right. So today and tomorrow, same link, right? We'll keep the same link. I will leave the link for the same thing. So tomorrow also same link will go. Without any more further delay. We'll start. Okay. Fine. I hope all of you have the tutor, right? Have the tutor also nearby. Eyes on the screen, ears on the speaker. Listen very carefully. Right. Hydrostatic pressure. Hydrostatic pressure and its application. That's how the heading goes. Hydrostatic pressure and its application. Right. Leave hydrostatic pressure aside. First of all, what is pressure? First of all, Lamai, what is pressure? Listen very, very carefully. These are grade 9 section. What is pressure? What is this pressure means? Right. First, I will unmute y'all. Y'all tell me. Does anyone knows what is pressure? Anybody?
Force exerted on a surface for a unit
Force
time
is acting on
on
a
a unit area. Force exerted on a unit area.
Yes. Yes. Basically, the mind pressure, the definition of pressure is perpendicular force acting in a unit area. Where repeat with me? What is pressure means? Perpendicular force acting in a unit area. Perpendicular force means perpendicular. That means what? What's the angle should come into your mind? When you tell perpendicular, what angle should come into your mind? 90 degrees. So perpendicular force acting in a unit area is pressure. That means, right, listen. There you go. There you go. You have a certain area. This is a certain area. I'll name the area as A. I apply a perpendicular force there. Look at the board very carefully. I apply a perpendicular force there. A perpendicular force in this area. This is a perpendicular force. If I show you all, see, let's say this is the area. This is the area. In this area, now this pen is the force. Can you see this force is applied perpendicular? This force is applied. This pen is now pen is perpendicular 90 degrees. Perpendicular force acting in a unit area. Perpendicular force acting in a unit area. Perpendicular force acting in a unit area. So area is given, force is given. Here the angle is 90 degrees. From there you can make a basic equation. You can write pressure in terms of a certain equation. What is the equation for pressure? Pressure is equal to perpendicular force divided by area. Pressure is equal to perpendicular force divided by area. You can write it symbolically. Pressure P is equal to perpendicular force F divided by area A. Very important equation. P equal F divided by A. P equal F divided by A. Okay. What is the unit used to measure pressure? What is the unit used to measure pressure? Remember, in physics, don't go to memorize the unit separately. Memorize the equations. Don't go to memorize the unit. Memorize the equation. What is the equation for pressure? F over A. What is the equation for pressure? F over A. Now your turn. What is the equation for pressure? F over A. Pressure is force F over A. You all tell me. What is the SI unit of force?
Newton.
Divided by area. What's the SI unit?
Meter square.
Meter square. Very good. Meter square is the SI unit. Meter square. If I take it on top. Meter square. If I take it on top. Now this is plus 2. Now if I take it on top. Minus 2. So what's the unit of pressure? Nm to the power minus 2. How do you pronounce this? Newton per square meter. Or you can even tell Newton per meter square. Newton per square meter or Newton per meter square. Another unit is also there. What is that?
Pascal.
Pascal. Pascal is the SI unit of pressure. Keep that in mind. Pascal is the SI unit of pressure. It's the SI unit of pressure. Okay. Next. What is the fundamental unit of pressure? What is the fundamental unit of pressure? Now, those who come from my theory classes, they know what is fundamental unit. What is fundamental unit? Any physical quantity there is a basic unit. Fundamental means what? Basic. There is a basic unit. There is a fundamental unit. For any physical quantity, we have fundamental unit. How do you obtain fundamental unit? From the equation. New students, listen. How do you get the fundamental unit? From the equation. Now, for example, what is the fundamental unit of force? What's the fundamental unit of force? How do you get it? New students, listen. Tell me, Ramai, what's the equation used to measure force? First, tell me that.
F is equal to M.
F equal m. What is the basic SI unit for mass?
Kilogram.
What is the basic SI unit for acceleration?
ms minus 2.
Ms to the power minus 2. This is the basic unit for force. This is the fundamental unit of force. Fundamental unit of force. See, how did I obtain it? I obtained it from the equation. From the equation, the first unit that you get is the fundamental unit. So F equal MA. M is kg, A is ms to the power minus 2. This is the fundamental unit. This is a bit longer. As it is longer, we give a derived unit. Derived unit is Newton. Newton is derived unit. Kg ms to the power minus 2 is the fundamental unit of force. So how do you obtain fundamental unit? Don't go to memorize. Memorize the equation. I always tell. Physics, memorize the equation. Don't memorize units. Fundamental unit of force. How do you obtain? F equal ma. M is kg, A is ms to the power minus 2. You put them together. Kg ms to the power minus 2. That's the fundamental unit of force. 2019 or 18 MCQ question. Past period. Fundamental. Now, what's the fundamental unit of pressure? Work with me, work with me, work with me. Work with me, eh? What is the fundamental unit of pressure? F unit of pressure. What is the fundamental unit of pressure? Listen. Tell me what's the equation for pressure?
F4.
Force over area.
Force over area.
Force over area. What is the fundamental unit of force? We already wrote.
Kilogram.
kg ms minus 2.
Ms to the power minus 2.
Newton.
You can't apply the right unit. You need everything in the base form. You need everything in the fundamental form. Fundamental unit of force we know kg ms to the power minus 2. Why kg ms to the power minus 2? Mass is kg, acceleration is ms to the power minus 2. kg ms to the power minus 2. kg ms to the power minus 2 is the basic unit of force. What's the basic unit of area?
Meter square.
Meters.
Meter square. How much? Solve it. Solve it, Putin. Solve it. Kg is there? Yes, kg is there. M on top, m square on bottom. M divided by m square. Solve this.
M2.
1m. 1 square of the m will cancel off. Neither. That is maths. M in the denominator, if I take it on top now, m in the denominator can be my 1 over m. Take it on top and tell.
M minus 1.
M minus.
M to the power minus 1. S, there is no partner for S. So S will remain as it is, S to the power minus 2. kg, m to the power minus 1, S to the power minus 1 is the fundamental unit of pressure. Until now, in O-level paper, they have not asked the fundamental unit of pressure. They have only asked the fundamental unit of force. They might ask this. They might ask this. I don't know, they usually ask CRE, because this is a blank. We have a blank in the O-level paper. The blank is fundamental unit of pressure. Don't go to memorize. How did I obtain? Pressure is equal to force over area. Force fundamental unit is kg ms to the power minus 2 divided by area m to the power 2. After that, maths, you cancel the m's. Kg m to the power minus 1 s to the power minus 2.
Minus 2.
Kg m to the power minus 1 s to the power minus 2. Until here, it's not grade 10. It is grade 9. This part is only grade 10. We'll quickly write this name. I hope all of you have the tube. Take out the tube, take some color pens. Go to the tube. Go to the first page. Hydrostatic pressure and its application. Pressure. Perpendicular force acting in a unit area is pressure. Underline or highlight the definition of pressure. Underline or highlight the definition of pressure. Under that a box is given. Under that a box is given. In that box, first box, and in that first box, all these things should go with the drawing. I'll rearrange it like this. Zingarali. Nicely write down, eh? But once done, put a thumbs up. We'll go to YouTube. F to the power minus 2. Before in the screen it was not. F to the power minus 2. Ambi, no screenshot. Please write it. Screenshot still never work. It is only fill your gallery. One day when the storage is full, you will select everything together, you'll delete off. Another 1 minute, quickly work. Those who want, you in a separate paper do this derivation. Those who already finished, do this derivation. Without looking, try to do the derivation. How I got the fundamental unit of pressure. That's separate paper do. Anyway. Right. Right. Perfect. Go back to the tube. Next point. Result. Pressure. Scalar quantity or vector quantity. Let me try and explain also. What is scalar quantity? What is vector quantity? What is scalar quantity? What is vector quantity? Every quantity in physics is divided into two, scalars and vectors. Vector quantity. What is scalar quantity means? Scalar quantity means a quantity that has only a magnitude. Is there a direction? No. Only magnitude is there. Magnitude කියන්නේ ළමයි a value. Only a value is there, no direction. What is vector quantity? A quantity that has both magnitude and a direction. Any quantity should have a magnitude, a value should be there. So magnitude is there in both, but direction, a specific direction is only there in vector quantity. Scalar quantity, no specific direction. How to memorize this? Remember, scalars and vectors go in alphabetical order. A, B, C, D, එහෙම යනකොට ළමයි when you go like that අපි පොගමුවද S will come first, V will come second. Go in the alphabetical order A, B, C, D එහෙම when you go. S comes first, V comes second. V won't come first and S won't come second. S alphabetical order. S comes first, V comes second. S comes first, only one thing is there, magnitude. V comes second, two things are there, magnitude and direction. Memorize it like this. But don't go to the exam and write. V comes first, S comes first, V comes second. This is for you to memorize. Because most of students get confused. Without confusing, S comes first, only magnitude is there. V comes second, two things are the magnitude and direction. So now the question is pressure. Pressure is vector or scalar. It only has a magnitude, it has a magnitude and a specific direction. Remember, pressure only has a magnitude. There is no specific direction. And is why? No, perpendicular force is there means there should be a direction. No, there is no specific direction. It only has a magnitude. I will prove it when I am teaching you all the characteristics of hydrostatic pressure. When I am teaching hydrostatic pressure characteristic, I will prove that pressure doesn't have a specific direction. It acts in all the direction. It acts in all the direction, no specific direction. No specific direction, none is a scalar quantity. For now, just memorize and keep. Later on the characteristics of hydrostatic pressure, I will do that. So remember, hydrostatic pressure. Pressure is a scalar quantity that is given there. Please underline or highlight it. Pressure is a scalar quantity. Underline, highlight. Don't make it big to the Finally, what's the relationship between Nm to the power minus 2 and Pascal? Both are unit used to measure pressure. Pascal is the SI unit, Nm to the power minus 2 is another unit. What is the relationship between Nm to the power minus 2 and Pascal? Very simple. 1 Nm to the power minus 2 is equal to 1 Pascal. 1 Nm to the power minus 2 equals 1 Pascal. Now your turn. Now your turn. Now your turn. එහෙනම් tell me ළමයි. 5 Nm to the power minus 2 equal how many Pascal?
5 Pascal.
Pascal.
5 Pascal.
10 Nm to the power minus 2. 50 Nm to the power minus 2.
50 Pascal.
50 Pascal.
Equal in value. Keep that in mind. These two are equal in value. That second box, I want you all to write this. Second box. Write this.
I want to copy this in the second box.
Right. Perfect. Now, you all know the mathematical part of pressure. Pressure is equal to perpendicular force over area. All those are mathematical part you all know. But when I tell pressure, is there any idea coming into your mind? Mathematically, you know pressure given perpendicular force divided by area, unit is this, it's a scalar quantity, fundamental unit is this. You know mathematical part, you are 100%. But when I tell pressure, is there an idea coming into the mind? Now, when I tell mass, a certain idea is coming into the mind. Amount of substance. When I tell force, push or pull, the idea is coming in. But when I tell pressure, is there a proper idea coming into the mind? No. Think like this one. Pressure means a squeezing feeling. Pressure means what? A squeezing feeling. Record in the mind like that. Pressure means a squeezing feeling. Now, this bottle is there. We'll take my traditional bottle. This bottle became famous more than me. All my classes, I use this one to explain something. Hi. Now this bottle. Now this bottle is there. If I squeeze the bottle, that means what I am doing? I am applying a pressure. If I squeeze the bottle, I am applying a pressure. If I squeeze it more, I am applying more pressure. That is that pressure concept. When I squeeze the bottle, that now what bottle is feeling, not what I am feeling. What bottle is feeling is the pressure. You take your friend and you squeeze that fellow. He's feeling a pressure. That pressure only causes a pain in him. In human, we feel a pain when there is a pressure act. That squeezing only causes a pain. Now it doesn't need to be you going and externally squeezing. Even let's do something like this. Let's take this book is there. Ignore my hand and this book is just there. If I keep the bottle on top of this, now see, this bottle is facing the book. Just practically think. If I keep the bottle on top of this bottle is squeezing the box due to the weight there. It's squeezing the book there. So now the book is feeling what? The pressure. It doesn't need to be you going and externally squeezing. It can be just an object on top of another object. So this book is now feeling a. You keep this bottle on the table. You are squeezing the table. Practically. Keep this on top of a table. You are squeezing the table. Table is feeling a pressure. You keep it on top of sand. You are squeezing the sand. Sand is feeling a pressure. That's why sand goes a little bit down. Now understood what is this pressure means? A squeezing feeling. It doesn't need to be you going and external squeezing. You keep something on top of something. You are squeezing. You are now, let's say you are standing on a tie. You are squeezing the tie. You are applying pressure on the tie. If you stay away, you are not squeezing that. Right? You keep your laptop or the phone on the table. For using the laptop or the phone, you are squeezing the table. Table is feeling a pressure. That is that pressure. So hereafter, when someone tells you pressure, what should come into your mind is a squeezing feeling. Understood? Mathematical part also now clear. The feeling part also now clear. Now we'll go to the questions. Questions. First one I will do, second one onwards you have to do. So first one listen, see how I do. See how I do the first one. Question 1. I hope the board is clear. However, I have given the tutor already. A perpendicular force of 100 Newton is acting in an area of 5 meters square. Calculate the pressure exerted. I want you all to work in your writing book. My normal theory students, you are writing your writing book, write down the main heading hydrostatic pressure and its application. Under that you are going to work. See how I do. First listen. Question number 1. What are they telling? They are telling the perpendicular force is 100 Newton. Area is 5 meters square. Always in calculation type question. Write the data separately. Then do the question. Both in maths and science. That saves your time. Listen, it saves your time. Huh? It surely saves your time. You think writing the data separately will spoil the time? Nah. Believe me, it saves your time a lot. From grade 11s. Once you start solving q equals mc theta like questions, it saves your time a lot. Alright. So here the data is perpendicular force is 100 Newton, area is 5 meters square. I'll write the data separately. Perpendicular force is 100 Newton, area is 5 meters square. What are they asking? They are asking the pressure. Always calculation question, it's a must to start with the equation. What's the equation for pressure? Pressure P equal F over A. Now apply the values with the unit. With the unit. Force is 100 Newton. 100 Newton. Force is not 100. 100 is a number. We are not dealing with numbers in science. We deal with numbers in maths. We deal with physical quantity in science. Physical quantities have a unit. It's a must to indicate the unit. I'm not writing 100 as a number. I'm writing 100 as a force here. If it is a force, you need to write the value as well as unit. It's a must. If you don't write it, no marks. 100 Newton divided by area is 5 never 5 is a number. 5 meters square. Now do the math. 100 divided by 5, how much? 20. Nm to the power minus 2. Or directly you can keep it as 20 Pascal. Always keep the final answer in Pascal. Unless and otherwise they tell you to keep it in Nm to the power minus 2. Try to keep it always in Pascal. 20 Nm to the power minus 2, that is 20. I hope the calculation part is clear. In your item of write down hydrostatic pressure and its application. Under that questions, do the first question. You all do. Do this and you all do. Question 2, question 3, question 4. You can do no calculators. No calculators. Train your brain. Whenever when you get a chance to train your brain, train your brain. Don't allow calculator to train the brain. Now you are not in a stress or anything. Now you are not in exam environment. So now use your brain. Not everyone will get the chance to train the brain. Do the first question and you all do 2, 3, 4. Meanwhile, I will update my battery. When you are done, tell me done. Yes, think and do. Sometimes they are giving kg. You have to think, you train your brain. First and done, no. I'll put the CO10T. I don't know why it's not becoming bigger today. Read it. Once done, send me the answers. Send me with the question number. Second one, third one. I specifically want the third one answer. Right. Right. Good. Most of you got the answer. I'll do the second one. A perpendicular force of 300 Newton acting in an area of 0.15 meters square. 300 Newton, 0.15. There you go. Question 2. Force is 300 Newton. Area is 0.15 meters square. Write the equation pressure P equal F over area. If it is a MCQ question, of course, you can do it in the mind. I am solving this like essay and structured essay question. Essay structured essay, this is the methodology. MCQ, you will do it in the mind. Some people 300.5, they can do it in the mind. Chop the decimals and you can do it. Pressure is equal to 300 Newton divided by 0.15. You can do this in the mind while reading the question. If it is MCQ question, in the mind you can solve it. 300 divided by 0.15. For that you should get rid of calculator now. Now you train the brain, automatically that ability will come. So pressure is, now jump decimals. Some fellows can't divide 300 by 0.15. Lajja 300 divided by 0.15. What you do? Jump decimal, you multiply by 100. When you jump decimal, multiply by 100, 300, another double zero. This side, another double, you multiply by 100. You jump decimal, 15. Can't you divide this? to 2000, directly I write the answer as 2000 Pascal. P capital, Pascal P capital. How did you get 2 zeros there? I multiplied by 100. Top and bottom, I multiplied by 100. That's max. Okay. So then you put it. I have it. I put it after the class. I actually slept until about 8:45, 8:35. Yesterday, goal class finished. When I was leaving goal itself, it was 9 o'clock. Checking was there. For the election, a lot of checking before putting the vehicle into the highway. Big checking was there. And once I entered the highway, somewhere 9 and 30. When I reached home yesterday, 12:30 something. And then only I update while coming only I updated your link and the things. The service area. So today slept a little bit, directly started the class. After the class only I should go and vote. Hi. Question 3. A girl of mass 50 kg is standing on a tile of area 0.1 meter square. Model question. Girl of mass 50 kg. Mass is given. Standing on a tile of area 0.1 meter square. Calculate the pressure. 50 kg 0.1 meter square. 50 kg. Question 3. Mass of the girl is 50 kg. Area is given point 0.1 meter square. Now, Panna don't go to do this. Minimum 50 you can divide by 0.1. 50 is mass. Pressure is equal to force over area, not mass over area. Your first job is you need to find the force here. The first job is to find the force. Now think practically, think on the tile is there. This is your sibling standing on the tile. Mass of this girl is 50 kg, it says. To calculate pressure, pressure is equal to force divided by area. You need the force exerted by the girl. Girl's mass is there 50 kg. You need the force there. Y'all tell me. If mass is 50 kg and someone is standing like this, what is the type of force acting? What is the type of force acting? For theory class students, under forces I taught you, types of forces. When a girl is standing, anything, standing, what is the type of force? Very good. The type of force is weight, or you call it gravitational force. So the type of force here is the weight force. Now next question is how to calculate weight. Tell me the equation. How to calculate? Mute. How to calculate the weight? Put weight
Mass into gravitational.
Mass into gravitational acceleration.
Gravitational acceleration. W equal
Mass
H.
into gravitational acceleration.
Mass is given 50 kg. Now, if it is MCQ question, you one shot can tell. 50 kg now, how much is the weight? One shot tell.
500 Newton.
25 mathematics. Gravitational acceleration is 10 ms to the power minus 2 multiply 500 Newton. So the force is 500 Newton. That is what we need, not the mass. Now we have the force 500 Newton. Now put it to the equation, get the answer. Now nothing big. Pressure is equal to force is 500 Newton divided by area is 0.1 meter square. Again, jump decimal, jump decimal. Max part you can't ignore, you can't use calculator, jump a decimal. Multiply by 10, multiply by 10, jump a decimal. 5000 divided by this side also jump a decimal 1. 5000 divided by 1 is 5000. 5000 Pascal. Question. Convert this to kilopascal. Let's see who can do it. Mannaputhi from nowhere.
5 kilo. 5 kilopascal.
5 kilopascal.
Nothing big lamai. Kilo kiyanne 1000. Tell me 5000 grams. How many kilograms?
0.5 kilograms.
5 kilo.
එතකොට 5000 pascal. How many kilopascal?
5 kilopascal.
Loud.
5 kilopascal.
5 kilopascal.
You don't need to give the answer like order because sometimes in the exam they will tell. Give the final answer in kilopascal. එතකොට don't start scratching up and down, scratching your head up and down. You divide by 1000. It's like gram to kilogram. Excellent. Fourth question, Dad. Fourth question, Dad. Raise the hand. Those who are done. Tingala raise the hand. YouTube people are done. We forgot about it. This question also right. Alright. Perfect. We'll go to the fourth question then. When a pressure of more than 10,000 Pascal acts on a bridge, the bridge would collapse. So that is how these bridges collapses. Huh? Sometimes you would have heard the bridge just collapsed. In India, there was a recent instance where a hanging bridge, of people were walking on it more than the capacity, more than the required capacity. There was a set of people walking there, right? So that bridge collapsed and fall down. It was a huge disaster. It was a huge problem in India. Recently, there was a issue. I don't know whether you all knew that. So, however, bridges are there. When more than a certain amount of pressure is acting, guaranteed it will collapse. Not on the bridge, anything is like that. Let's say you get on top of a regiform will collapse. When a pressure of more than 10,000 Pascal acts on a bridge, the bridge would collapse. If the mass of a car is 100 kg, calculate the minimum area of the bridge for one car to travel at a time. These are questions, practical questions. Maximum pressure that can act on the bridge is 10,000 Pascal. More than that means bridge will collapse. Mass of a car is 100 kg. Then calculate the minimum area when you are building the bridge. How much of area you should keep there? Calculate the minimum area of the bridge for one car to travel at a time. When you are building a bridge, let's say you become an engineer, you are building a bridge. When you are building a bridge, you need to do these calculations. How many vehicles are going to travel? Then how much is the area you keep? The question is, maximum pressure that can act there is P max is 10,000. 10,000 Pascal. Mass of a car is 100 kg. Mass is given. First of all, tell me, can we do this question using masses?
Answer.
And convert it into force. Mass now, what is the force? Weight. Tell me the weight.
1000 Newton.
1000.
1000. What are they asking? What are they asking? They are asking the area. Pressure is there, force is there, area they are asking. Remember, in an equation, if there are three variables, they will surely give two variable. You need to find one variable. That is how equation works in maths. Three variables are there, and two will be given, one you should find. P is given, F is given, can't you find area? Yes, you can. P max is 10,000 Pascal. F is 1000 Newton. Please write with the units. Please write with the units. Area you don't know. What you don't know, keep it as A. If you need to find A, you need a subject A. If you subject A, now you are to tell me, if you subject A, denominator goes to the up, then this one goes down there. So area is equal to 1000 Newton divided by 10,000 Pascal. 1000 divided by 10,000 is 0.1 meter square. Small bridge. 0.1 meter square. How to convert force and mass? And put it. If there is a mass, let's say mass is 10 kg. How to convert it to force? Force is the weight. How to find the weight here? You multiply it by gravitational acceleration. Mass you multiply by gravitational acceleration. Gravitational acceleration on Earth is 10. That you multiply by 10. Can't be multiplied. We switch this thing. What is this? This is cross product. You cross it. Area goes on top, 10,000 comes on. There is max. You switch it. Okay. Now do fifth question. One question is there, fifth one is there. Yeah. Do the fifth one. Think and do. I think and do. So how the answer 0.1 meter square comes? So 11. Okay. This is there, that is there. Area you take on top, 10,000 you take bottom. 1000 divided by 10,000 is how much? 30, 30 cancel out, 1 over 10. 1 over 10 is how much? Fine. Do the fifth one. Fifth question. Once done, tell me done. And send me the answer. Quantity is mass. And give mass also. Max will come every time. Can't get rid of max. This one done. I'll share the screen. Fifth question. Page of the fifth question and send me the answer. Contact surface area of each tire, each tire 0.2. Okay. Question 5. Question 5. A Jeep has 4 tires and the contact surface area of each tire is 0.2 meter square. Each tire 0.2 meter square. One tire 0.2 meter square. You all tell me what's the
0.8.
overall contact surface area?
0.8 meters.
8.
One tire 0.2 meter square now. 4 tire 0.8 meter square. So from that you can tell area is 0.8 meter square. One variable is there. Maximum pressure that clay soil would withstand is 16,000 Pascal. Pmax is there. 16,000. Now with experience you all know. If the Pmax is there, what they can ask? The force. That means the weight of the Jeep. From there they can ask the mass if they want. Calculate the maximum and the mass. Calculate the maximum mass of the Jeep, including the passengers. Before going to the mass, we'll first calculate the weight. That is what we can calculate. Apply the equation. Pressure equal force over area. Force is 16,000 Pascal. Sorry, pressure is 16,000 Pascal. Force you don't know. Force is the weight of the G. I'll keep it as W divided by area there is 0.8 meters square. Now max and denominator. Now you all tell me. If I need to find W, I need to subject W. If I subject W, 0.8 should go to the other side. Denominator on the other side become
Numerator.
Multiply.
numerator multiply. So this goes to the other side, it becomes multiplication. So W equal 16,000 Pascal multiplied by 0.8 meter square. Now max, weight of the GP is 16 into 8. 16 into 5 is 80. 6 is 96. 6, 7, 96. Another 2 is 32. එතකොට ළමයි 8 there 12. 1 to 8. 0.10 cancel off, then 00. 12,800 Newton. That's for the final answer. You will get 12,800 Newton as the
No, sir.
Yes, sir.
Yes, sir.
asking the weight, not the final answer. Weight is 12,000. 12,800 Newton. They are not asking 12,800 Newton. What are they asking? They are asking the maximum mass. Now convert it into mass. How to convert it into mass? W equal mg. If you want, you can write the equation and tell, but one shot also you can tell the mass. Tell me one shot, tell me the mass.
1200
1280.
kilograms.
Mathematically, if I show 12,800 Newton equal mass, you don't know. Gravitational acceleration, 10 ms to the power. From the other mass is you multiplication go to the other side division. 12,800 divided by 10 is going to be 1,280 kg. So G with the passenger 1,280 kg. Practical question. Maybe they can extend the question. I'll extend the question and ask. Roman 2 now. If the total mass of the jeep with the passenger is, if the total mass of the jeep with the passenger is 1,500 kg, what will happen to the jeep when it is moving in the clay soil? Get it. First, tell me, all put the hands down. So many are raising. All put the hands down. Now the question is asking Roman 2. If the mass of the jeep with the passenger is 1,500 kg, what will happen to the jeep? Who is going to answer? Is
The
that?
pressure increases.
Yeah. Right. Now I want practical answer. Scientific way. Practically, what is going to happen?
It will sink.
And jeep will sink. In the mud, it will sink. But to avoid that, Roman 3 now, right? To avoid that, what is the speciality in jeep? Jeep tires.
4 into 4.
Off-road tires.
Area is increased. Avoid friction.
If you look at the area of the jeep tire, area of the jeep tire is increased. Why the area of the jeep tire is increased? Huh?
To reduce the
Divide the
pressure
pressure.
exerted on the mud.
Increase the pressure.
Pressure equal force over area. When denominator increases, area increases. Final answer?
Pressure decreases.
Decrease.
Decreases.
When denominator increases, indirectly proportional. When denominator increases, final answer will decrease. So that is why jeeps have 30 big tires to go in off-road. In that off-road, you can't go in normal tire vehicle. They can ask question. Alright, that's it. Pressure part is done. Any doubts on pressure part? Dingal ask me, I'll give you 1 minute.
No, sir. No, sir.
No, sir.
Why is there patterns on the tire? You all itself tell me. One of you tell me why there are patterns. You could call it grooves. Grooves on tires.
Friction.
To avoid the
Avoid slippage.
friction.
To avoid slipping. So how did you find the force in the fourth question? Fourth question. Fourth question. Fourth question. The fourth question. When a passenger of more than 10,000 Pascal acts, when a pressure of more than 10,000 Pascal acts, mass is 100 kg. Mass is 100 kg. What is the weight? The person asked me itself, if the mass is 100 kg, what's the weight? Yeah, mass is 100 kg given. Then what's the weight? 1000 Newton. That's how you find it. Alright, basic things. Right. So pressure part is done. Now only we are going to start the lesson. This much of time it is pressure. The lesson name is hydrostatic. Now only we are going to start the lesson. Hydrostatic pressure. Now we all unmute until I explain and finish. You all mute, unmute. Maybe. Mute. Now only we are starting the lesson. Hydrostatic pressure. Right. Eyes on the screen, ears on the speaker. Listen very carefully. Hands not on the food, eh? And then you. Hydrostatic pressure. What is this hydrostatic pressure means? The pressure felt inside a fluid is hydrostatic pressure. The pressure felt inside a fluid is hydrostatic pressure. Best example, you go for swimming. You go under the water. You feel a squeezing feeling, isn't it? Yes or no? Tell. When you go for swimming under the water, when you go, you feel a squeezing feeling. Now you all tell me, squeezing feeling is what? Squeezing feeling is what? Pressure. Ears, everywhere you will feel a squeezing feeling. Understand? Pressure. So pressure felt inside a fluid is called as hydrostatic pressure. So for that pressure, you give a special name. That is also pressure. No changes. Squeezing feeling, that's also pressure. But you give a special name to that pressure. What is the special name? Hydrostatic pressure. There's an equation to calculate hydrostatic pressure. What is the equation to calculate hydrostatic pressure? Listen very carefully. There you go. A big tank. Big tank. Inside that, you have a certain fluid. Let's say a point A. Point A is at a depth of h. Depth is h. H can be 1 meter, 2 meter, 3 meter, 5 meter, 1000 meter, whatever you want. Whatever you want, you can think. Point A is at a depth of h. I take the density of this fluid. Density of this fluid as. Oh no, what is this? Answer. This is P. P never put up. This is rho. Yes. It's a Greek symbol. Rho. Greek symbol. That's how you pronounce it. Usually density is denoted by rho. Maybe you put a C. It's not P. Letter P is this. Slight bending is there. Rho. So I take the density as rho. Gravitational acceleration. Usually gravitational acceleration is taken as simple G. I'll use the same notation, simple G. Right. So these things are given. From there, you can find the hydrostatic pressure. How to find the hydrostatic pressure? Remember, hydrostatic pressure at point A. Point A is here. Hydrostatic pressure at point A is equal to depth of the liquid, that is h, multiplied by density of the liquid, that is rho, multiplied by gravitational acceleration, that is g. H rho g multiplication gives you hydrostatic. Simple. Depth into density of the fluid in gravitational acceleration. Okay. What is the unit, Puti? What is the unit? No changes. What's the? This is also pressure. Pressure. Tell me what's the unit? Pascal. Pressure unit is Pascal, no change it. It is Pascal. What is the gravitational acceleration on Earth? G on Earth. On Earth, what is the gravitational acceleration? 10 ms to the power minus. Gravitational acceleration on Earth is usually this equation is written for Earth. The gravitational acceleration on Earth is 10 ms to the power minus. Second, listen, what is hydrostatic pressure? The pressure felt inside a fluid. To calculate that, you need the depth of a certain point, density, and gravitational acceleration. Depth into density into gravitational acceleration multiplication gives you hydrostatic pressure. Unit is Pascal, G on Earth is 10 ms to the power minus. Once when you start doing questions, you will understand. What is that Greek symbol? What is that Greek symbol? It's a Greek symbol. It's a Greek symbol, rho. Symbol is density. For density, usually we tell. Okay. Huh. What is the due? Hydrostatic pressure. Pressure acting in a fluid is called hydrostatic pressure. Pressure acting in a fluid is called hydrostatic pressure. Under that, the first box. In that first box, I want you all to nicely draw this and write it. Nicely do it. Oh, yeah, but here it's current. Vandadu ponadum seiradilla. Nicely write it. Do some color pens. So how can I get the tute? Tute is there in the group as well as in the YouTube live streaming. Under the description section, I uploaded the tute. So are you in Candy? Not to come, just to I am in Colombo. So most of the students in my class are using an equation. It's equal V rho G. Why? Most of the students in my class equation. HP equal V rho G. V rho G is not the equation for hydrostatic pressure. V rho G is the equation for upthrust. H rho G is the correct equation, right? Thank you, sir. So for whom did you put the election? Still I will vote. When I'm voting, I'll put it for the correct person. So when you see a Friday class information, you all text and ask in the WhatsApp to that me. So can you give washroom break? Anime, I know about y'all. While I'm teaching, y'all will run and go and come. Take it up in a break at home and only personal questions. Okay. Ask question related to the lesson. What HPA means? Hydrostatic pressure at A. hydrostatic pressure at A. For A only we are calculating. For a certain point only we calculate the hydrostatic pressure. So shout out to Eastern students. No any question from the youth? Fine. I hope all of you are done. Right. Now I have a question. Now, hydrostatic pressure is a type of pressure. Hydrostatic pressure, it's a type of pressure. It's pressure. Now, y'all tell me, what's the equation for pressure? Unmuted. Tell me. Pressure, what's the equation? Normal equation. Wait, I'll allow you all. Unmute. What's the equation?
Force over area.
Perpendicular force over area.
Perpendicular force over surface area.
What's the equation for hydrostatic pressure? We don't have any connection between these two equations. We don't have any connection between these two equations. You look at the equation. Even the quantity is there doesn't have any relationship. Then how come both the equation for pressure? This is the base equation for pressure. Hydrostatic pressure and it's also pressure. Pressure inside the fluid. There is no any direct relationship between this and this. Then how come both the equation for pressure? How come that is correct? Actually speaking, this equation, which equation? This equation is obtained from this equation. This is the base equation for pressure. Pressure equal force over area. From this one, we derive and take this equation. I'll prove how we derive and take. But before that, why we use this equation for fluid pressure? Why we use H rho G equation for fluid pressure? Why can't we use this equation for fluid pressure? The problem is this. Inside a fluid, I take a point A. Define me a force for point A. Can we define a force for point A? Or at least that, let's say you somehow define me an area for point A. Think about that question I'm asking. Define me a area for point A. So can you find the pressure at point A in a fluid using F over A equation? Can you find? F over A equation, can you find the pressure at point A in a fluid? No. That's why you readjust the equation into this. Now this you can define. Depth you can define, density of the fluid you can define, gravitational acceleration you can define. These quantities you can define for a fluid. These two quantities you can't define for a fluid. Therefore, you rearrange the equation and obtain it. How rearrange the equation and obtain? I'll show that. That part is not there in the syllabus, but now some fellows are there, they will ask me, so how this and that doesn't I'll prove that. And this is for your science knowledge, not for your exam knowledge. This is for your science knowledge. Alright. How H rho G came from P equal F over area. Pressure. Pressure is equal to force over area. What is the force we are talking about? Force is the weight. The force we are talking about is the weight there. So the force is the weight. Weight divided by the area there. Correct? What is the weight? Pressure is equal to weight over area. You all tell me, how do we find weight? What's the equation to find weight?
mg. Mass into gravitational acceleration.
So instead of
The
W,
mass into gravitational acceleration.
so instead of W, I can write mg. Instead of W, I can write mg. Mg divided by. I'll name this as equation star. Right. Keep that aside now. Grade 9 question. What is the equation for density?
Mass by volume.
Mass by volume.
Mass over volume.
Okay. Density is mass over volume. Grade 9 work, okay? Density is mass over volume. For a certain reason, I will subject the mass here. If I subject the mass here, P goes to the other side. Denominator on the other side become multiplication. The mass is equal to density multiplied by volume. Mass is equal to density multiplied by volume. I'll name it as equation double star. I have two equations now. By equation star and equation double star, I can do something like this. Equation star is P equal mg over area. That is P equal, you all tell me now what is m. We already have equation for m. What is m?
Rho V.
So instead of m I can write, listen, instead of m I can write rho of m I wrote rho. Then g will remain as it is, area will remain as it is. See, instead of m I wrote rho. Taking this one more step ahead. Write that P equal rho Vg over A. One more step ahead. Rho volume. Volume I can split it and write it. Area into height. Just practically think. Volume of a cylinder. This is area. This is height. Area and height. So instead of volume I can write area into height. Instead of volume, area into height. G will remain as it is, divided by area will remain as it is. How max? How max? Area in numerator, area in denominator. What will happen? Yes. What is remaining? Rho is
Rho G.
H is remaining, G is remaining. Rearrange H rows. From this, that. How? So remember, this is not a different equation. That equation is obtained from this. Okay. Right? Don't go to think how this came. Right? This is for your science knowledge. P equal F over A. M you can rearrange and go. It's nothing big. F is the weight. Weight is mg. First equation. P equal, then after that separate equation, density equal mass over volume. For a reason I subject mass. Mass is density. Putting both of them together now work with the equation. P equal mg over A. M is rho V. Rho V G over A. Rho V G over A. V is AH. A and A cancel out. Don't go to think about this, you will get confused. Or you will get confused. What I wanted you to know is that this is not a separate equation. This came from this. You can't prove whether egg came first or the chicken came first. But you can prove H rho G came from P equal F over A. That you can prove. That I can do. You want to take a screenshot and keep later on, use it and slowly do. Don't go to think about it. You think about it today, remaining work we can't do. You all sit and slowly do. Of this came from that. Alright. So that is that. One more final point. One more final point. We know hydrostatic pressure is rho g. Using the equation, you all tell me depth h is depth now. When depth increases, what will happen to hydrostatic pressure? It will also what?
Increase.
Increase.
When h decreases, when the depth decreases, what will happen to hydrostatic pressure?
Decrease.
Increases.
Not only that, density. When density increases, hydrostatic pressure.
Increases.
Increases.
When density decrease, hydrostatic pressure.
Decreases.
Decrease.
And I told you gravitational acceleration, we apply this equation 99% for Earth. In Earth, gravitational acceleration is 10. So there you don't consider changes unless and otherwise they will take a base and then you go to moon and Neil Armstrong is bathing in the moon or if then G will change. Anyone have done it, G won't change. So if H changes, HP changes, if rho changes, HP will change. In that second box, I want you all to write that. But
Done, sir.
okay.
Sir.
Okay.
Okay.
Hari sir.
Finish.
Right, perfect. We'll start doing some questions. Question 1, I will do 2 onwards, you are going to do. Question 1. Calculate the hydrostatic pressure acting in a liquid of density 300 kilogram per meter cube. Density is given 300. At a depth of 2 meter from the surface, gravitational acceleration is given 10. See how I do, first see how I do. Hydrostatic pressure part. Question 1. Liquid of density 300. Density, rho is given 300. Unit for density is kilogram per meter cube. These are grade 9 work. Depth is 2 meter. H is given 2 meter. Gravitational acceleration we already know 10 ms per pound. They are asking hydrostatic pressure, nothing big. You can do in the mind itself. Hydrostatic pressure is equal to H rho G. H is 2 meter, density is 300 kilogram per meter cube. Gravitational acceleration 10 ms to the power minus 2. From there, the hydrostatic pressure is 300 into 600, 600 into 10, 6,000. Directly you can give the answer. Some fellows will ask this question also. How we are getting Pascal? Oh no, they are do that also. See, meters are there multiplied by kg m to the power minus 3. Multiplied by ms to the power minus 2. Solve this entire kg is there. M square m to the power minus 3. What's the answer? M square m to the power minus 3. What is remaining?
M to the power 1.
Plus the minus
Minus.
m to the power minus. So the m part is equally remaining h to the power minus. Power minus 1 h to the power minus 2. This is a fundamental unit of what?
Precious.
Right? That's pressure. Okay. So you can prove it using fundamental unit. You get the same unit. To the first question. To the first question. And you all do question 2 and question 3. Well, do we put that A thing under HP? No. There I put A thing, put that is because I took point A. Here point A is not given, but just you can use HP.
Sir,
Yeah.
I printed my tute. In the second question, what is the number? 1.5 meters?
Again question 11.5 meters. Depth is 11.5 meters.
Thank you, sir.
Okay. I'll share the screen. Do question 2, question 3. Question 3, don't use calculators. And send me the answer. All of you work. Work, send me the answer. Yes, good. Most of you are sending the answer. But I'll finish off the second one. Second question. Calculate the hydrostatic pressure acting on a diver. Diving at a depth of 11.5 meter. H is there, 11.5. Density of water 1000 kilogram per cubic meter. Gravitational acceleration 10. Question 2. Depth is 11.5 meter. Density of water is 1000 kilogram per cubic meter. Gravitational acceleration 10 ms to the power minus. Apply the equation. Hydrostatic pressure is equal to H. H rho G. H is given 11.5 meters. Multiply. Density is given 1000 kilogram per cubic meter. Gravitational acceleration is given 10 ms to the power minus. Do the math. 11.5 into 10 is 115. 115 into 1000 is 115,000 pascal. Big numbers, maybe you can keep it in kilopascal. 115 kilopascal. Any answer? It's not a must to keep it in kilopascal. I show both the ways because then it goes into your mind. That is kilopascal. That some student feel scared. Question 3. Maximum hydrostatic pressure that eardrum can bear is 1.013 into 10 to the power 5 pascal. Now, pressure is given. Maximum hydrostatic pressure is 1.013 into 10 to the power 5 pascal. Now, pressure is given. Calculate the maximum depth a diver can dive without any ear protection. Gravitational acceleration is also given 10. What did you take as the density? Density is given in the previous question itself. Density of what is how much?
1000
1000.
1000. The density is given in the previous question itself. So density is given 1000 kilogram per cubic meter. Is it a must to change to kilopascal? No, it's not a must. It's not a must. Unless and otherwise they ask you. Do it. Third one. I didn't get any answers for third one. They are given hydrostatic pressure, they are given the gravitational acceleration, they are given density. They are asking the maximum depth.
10.13 meter.
Perfect. Always remember now hydrostatic pressure. What's the equation? Hydrostatic pressure is H rho G. In an equation, now here there are 4 variables. If there are 4 variables, 3 they will give. 1 they will ask. HP is given, G is given, rho is given, H they ask. HP is given 1.013 into 10 to the power 5 Pascal. Depth is not given. That is what they are asking. H is given. H is not given. Density is given 1000 kilogram per cubic meter. Gravitational acceleration is 10 ms to the power minus 2. Okay. If I need to find H, I need to subject H. If I subject H, all the other things go to the other side. You all tell me multiplication on other side become what?
Division.
Division.
If I subject H, I will remove the units and write. Then easy 1.013 into the power 5 divided by 1000 into 10. Height will come in meters. If I take this one more step ahead, that is 1.013 into 10 to the power 5 divided by 1000 into 10 is 10,000. 10,000 is 10 to the power 4. 10 to the power 5, 10 to the power 4. You can cancel them. 10 to the power 4 will cancel off. 5 will cancel. 1 is remaining. 10 to the power 1 is remaining. 10 to the power 1 is 10. 1.013 into 10 means 10.13 meters. These are real values. So when a diver is going under the water, diving, you should actually go with ear protections. Not only diving, even when you do swimming, have you all seen? With the goggles, there's a small screw-like thing, a plastic screw-like thing is there. Most of the people throw it. You don't know the use of it. It's a must to put it. You put it and only you go under the water. Why? After you pass 10.13, pressure is very high. Our eardrum cannot bear that pressure. Eardrum can burst off. These are real values. Without any ear protection, maximum depth that a diver can go is 10.13. How did I get it? Apply the equation, substitute the values. After that, this part is max. You need to subject H, multiplication, go to the other side, division. 1.013 into 10 to the power 5 divided by 1000 into 10 is 10,000. 10,000 is 10 to the power 4. 10 to the power 4, 10 to the power 5 cancel off from there 1. What if it bursts? Nothing will happen. Only problem is you won't hear when someone calls you. For third question, they haven't mentioned the density. It's not mentioned because in the previous question they have given the density. Burst or implode. First it will implode, it will get pressed inside. Then it will burst. Actually, you can feel it. Keep your hands like this and press it a little bit. You keep hand in a palm. Keep your palm there and press it. You feel a implosion there. Not explosion, it's an implosion. Inside it gets plus. It gets plus too much inside and it gets so strong. How did you get the rho value? Rho value is given in the previous question itself. That's why I didn't give here. Method dive question. Actually, this should be the second part of the second question. In the previous question, density of what is given? 1000. Okay. Those are the calculation part of hydrostatic question. Do the fourth. One more question. Fourth question. Do the fourth question. Quickly work. Fourth question. Think can do. So how much deep we can go in water with ear protection? I correctly don't know the exact value, but you can find it out.
Sir, done.
Perfect.
Sir, done, sir.
Okay, now. Fine. Consider the following points in the fish tank. Calculate the hydrostatic pressure at A, B, and C. One by one will work. Density of water is given, gravitational acceleration is given, right? Question 4. There you go, you have a fish tank. You have a fish tank. Fish is not there, water is there. My total depth is 100 centimeter. 100 centimeter. This is point A. Point A is 10 centimeter. Point B 50 centimeter. Point C from the bottom 20 centimeter. They are asking the hydrostatic pressure at A, hydrostatic pressure at B, hydrostatic pressure at C. Work one by one. First, I will for the first one, hydrostatic pressure at A. Density and gravitational acceleration are given under that. Hydrostatic pressure at A is equal to H rho G. A, the depth is 10 centimeter. You all tell me, can we do the question using centimeters?
Can't, sir.
No, sir. Can we get a kg, m to the power minus 1, f to the power minus 2, bad? Everything should be in meters. So you convert centimeter to meters. Tell me 10 centimeter, how many meters?
0.1.
0.1.
Divide by
100.
10 over 100 meters. Am I get right? Multiply by gravitational acceleration, density 1000 kilogram per cubic meter. Gravitational acceleration 10 ms to the power minus. From there, how max? Some fellows are wondering, did you come for a science class or a maths class only? That is how this lesson is. 2 zeros in denominator, 2 zeros on top will cancel off. 100 into 10 is
1000.
Faster.
you're correct. Put it. Now you can't go wrong. Still you can't go wrong. Now this section should be perfect. Next one. Hydrostatic pressure at B. Roman 2. Hydrostatic pressure at B is equal to again H rho G. Hydrostatic pressure at B. Depth, the H is depth, always keep that in mind. Depth is 50 centimeter. Centimeter, you can't do the question. Centimeter to meter, you divide by 1000, divide by 100. So 50 centimeter divide by 100 meters multiply by density 1000. 1000 kilogram per cubic meter. Gravitational acceleration is 10 ms to the power minus 2. Do the math there. Hydrostatic pressure at B is equal to, there you go, 120, 120 cancel off. 5 into 100, 500, 500 into 10.
5,000.
5,000.
10,000 Pascal.
Roman 3. Hydrostatic pressure at C. HPG.
8,000 Pascal.
Hydrostatic pressure at C is my H rho G. And the question is, what's the depth of C?
100 minus 20.
What's the depth of C? 20
80
centimeter.
divided by
100 minus 20 centimeter.
20 centimeter is not the depth. 20 centimeters under C. We don't know. We don't want what is under C. We want what is above C.
50
80
centimeters.
Not the
centimeter.
20 centimeter. It's not the depth. We need the depth. Depth is from the top.
80 centimeter.
Tell me, Ramai, total length is 100 centimeter. This part is 20 centimeter. Now, what is the depth?
80 centimeter.
80 centimeter.
80
0.8
centimeters.
meters. 80 centimeters.
Listen. So keep in mind, H is not just some length. H is the depth. Depth is measured from the surface to that point. Not from the point down. From the surface to that point. 80 centimeters. So that part you need to do and start the question. So 80 centimeters. 80 centimeter convert to meters, 80 over 100 meters, density 1000 kilogram per cubic meter, gravity 10 ms to the power minus 2. 1, 2, 1, 2, 0 cancel off. 1800, 800, 810.
8000 Pascals.
1000 Pascal.
I'm pretty much sure.
Kilopascals.
First and second correct. Third one, if you have gone wrong, you have gone wrong. You have gone wrong, you have gone wrong. Second correct.
Sir, can you minimize the screen?
Okay, no. That's it, the calculation part. That's it, the calculation part. Now going through characteristics of hydrostatic pressure. What are the characteristics of hydrostatic pressure? Characteristics of hydrostatic pressure. First characteristic. Now listen very, very carefully. These things are very important. Characteristics of hydrostatic pressure. What's the first characteristic? First characteristic, I will teach it with a question. First characteristic, I'll teach it with a question. Special result is given to you. Special result is given to you. And it is filled with a certain liquid to the same level. Certain liquid to the same level. Liquid is filled to the same level. Look at the board very carefully. Now going to WhatsApp. You can send the message later. Message will stay. Message will remain. Let's take the level as. We'll take the level as 2 meters. The 2 meters is not given in the tube. Can you mark it? The level is 2 meters. Mark the level for the full this thing as 2 meters. Alright. Several points are given. Point A, point B, point C, point D. Density of the liquid there is 1000 kilogram per cubic meter. Gravitational acceleration is 10 ms per power minus 2. My question is, calculate me the hydrostatic pressure at A. Calculate me the hydrostatic pressure at B. Hydrostatic pressure at C.
So all are equal.
Pressure at D. Each one of them calculate and send.
So finished.
The pressures are equal.
Okay.
Yeah, that's the answer.
20,000 Pascal.
Okay.
Ondapute, we'll do it in the mind itself. Hydrostatic pressure is equal to H rho point A. H is 2. Put 2 in your mind. Rho is 1000. 2 multiplied by 1000. Do that in the mind. 2
2000.
multiplied by 1000. 2000. Multiply by G. 2000 you multiply by 10. How much?
20,000.
20,000. Hydrostatic pressure at A is 20,000 Pascal. Go to B.
20.
Ondapute, B also the depth is same. Same depth. Table is same na depth is.
Yes.
2 meters multiplied by 1000 multiplied by 10. How much?
20,000.
20,000.
Go to C. C also. Depth is same. 2 meters multiplied by 1000 multiplied by 10. How much?
20,000.
20,000 Pascal. Go to D. Depth is same. 2 multiplied by 1000 into 10. Again, how much?
20,000.
What does this tells us? Now listen very carefully. What does this tells us? Listen, eh? What does this tells us? See, A, B, C, D are different shapes. Containers are different shapes. Even though the containers are different shape, is the pressure changing? Is the pressure changing?
No.
No.
Louder.
No.
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 No. Even though the shapes of the container is different, hydrostatic pressure is the same.
Same.
Again, now tell me, again, does hydrostatic pressure depend on the shape of the container?
No.
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 Formally tell me, yes or no?
No. No.
No.
No.
Shape is different. Even the volumes are different. See, here only little bit of volume. Here a lot of volume is there. Even still, is the hydrostatic pressure different?
No.
No.
Second question.
No.
Does hydrostatic pressure depend on the volume of the fluid? Yes or no?
No.
No.
No, sir.
No.
Only height.
Even look at the surface area. Surface area, can you look at this area? This area and this area. Areas are different. But still, what can you tell about the hydrostatic pressure? They are
Same.
Equal. Same. Equal.
third question. Does hydrostatic pressure depend on the surface area?
No.
No.
Altogether, does hydrostatic pressure depend on the shape of the container, volume of the container, and the surface area? Yes or no?
No.
No.
Sir.
No, sir.
It only depends on the depth and the height there, density, and gravitational acceleration.
Gravity.
Changes, then guaranteed hydrostatic pressure will change. If the fluid changes, density will change, then hydrostatic pressure will change. If gravitational acceleration changes, hydrostatic pressure will change. It doesn't depend on the volume, it doesn't depend on the shape of the container, it doesn't depend on the surface area. Okay. Go to the view. characteristics of hydrostatic pressure. Calculate the hydrostatic pressure at ABCD. Did you mark this as 2 meters?
Yes, sir.
Mark it as 2 meters. Hydrostatic pressure value 20,000 Pascal. Work. Write the values there.
Done, sir.
Okay.
Finish.
Right. Under that point is given. Hydrostatic pressure does not depend on shape of the vessel, which means it does not depend on area of the vessel and even the mass of the liquid. Even the mass, now see, even the mass are different. Is it depending on the mass? Mass of the liquid within the vessel. Underline or highlight this first characteristic. Right. Second characteristic. Second characteristic. Look at the board very carefully. Remember, hydrostatic pressure in a given point. Hydrostatic pressure in a given point acts in all the directions. Is there a specific direction? Hydrostatic pressure in a given point acts in all the directions. So if I take this point, from this point, hydrostatic pressure acts there, it acts here, it acts there. All the direction you have. There is no specific direction. Not only 2D plane, now think 3D. Front, behind, now think this like a sphere. All the directions, I only do the 2D plane. Out of the board, inside the board, all those sides, hydrostatic pressure will be acting. Remember, hydrostatic pressure in a given point acts in all the directions. How to prove this? Simple. Take a bag. Show me bag again. You take a bag. Oh, you want a balloon? Very common. Fill it with water. You fill it with what? Water. And you put some holes. You put some holes. From this hole, which hole? From this hole, water will be coming out. From this hole also water comes out. From this hole also water comes out. From this hole also water comes out. Why? Why water is coming out in all the direction? Because from inside, water is getting squeezed in all the direction. Water is getting squeezed in all the direction. Tell me, what is squeezing feeling?
Pressure.
Pressure.
The
So pressure is acting in all the direction. That's why water is coming in all the direction. If pressure acts only in one direction, then water should come only in one direction. Squeezing happens in all the direction. Squeezing is the pressure. So pressure acts in all the direction. That's why the water comes out in all the direction. Okay. So second characteristic. Hydrostatic pressure in a given point acts in all the direction. Think 3D. Think 3D. Please underline or highlight the second characteristic.
Which one, sir?
Second characteristic. This one. Hydrostatic pressure in a given point acts in all the directions. Right. Proof. Take a balloon, fill it with water, and put holes in all the directions. Now, some fellows will tell answer it will blast off. Maybe you put some sellotape or something. When you paste a sellotape and put a hole, it might not blast. So take a balloon and fill it with water and put holes in all the directions at the same level. Water will be getting sprayed out in all directions. Characteristic number 3. Characteristic number 3. Third characteristic. Small points, but very important. There you go, you have a liquid. Someone is unmute.
వెంకాయం
Hi. I'll take several points. Point A, point B, point C. Using your previous knowledge, tell me, what can you tell about the hydrostatic pressure at A, B, and C? What can you tell about the hydrostatic pressure at A?
Equal.
It will be equal.
Equal.
Now put it to a nice sentence. Hydrostatic pressure in the same liquid, this liquid is same. In the same liquid or in the same fluid,
The same level is
the
equal.
same level,
Is
same
equal.
liquid,
Same level.
same level,
Is equal.
hydrostatic pressure is what?
Equal.
Equal.
I. In the same liquid, in the same level, hydrostatic pressure is same or equal. That's the third characteristic. Hydrostatic pressure in same liquid at same level is equal. Underline or highlight the third characteristic. We can prove it using a small experiment. Take a plastic bottle. You would have done this in your grade 1 or grade 2 or something. You would have done. Normally, this much big bottle. You take a small bottle. Or no, put a small bottle. Put some holes at the same level. Fill it with water. From all these holes, water will come out. What can you tell about the horizontal distance the water is getting sprayed? Same or different?
Different.
Same.
Horizontal distance the water is getting sprayed is same. At the same level, horizontal distance is same. IA. From inside, squeezing is the same. That's why the distance is the same. Squeezing same nang. What can you tell about the pressure? Pressure is
Same.
Equal.
same liquid, same level. Hydrostatic pressure is. That experiment is given. Proof. Take a plastic bottle, put some holes at the same level, fill water to a certain height. You will notice that horizontal distance traveled by the water coming out of every hole is the picture is there. Next one. Four characters. Four characters. There you go, you have a liquid. I'll take different levels. Point A, point B, point C. What can you tell about? What can you tell about hydrostatic pressure at A, hydrostatic pressure at B, hydrostatic pressure at C? Is it same or different?
Different.
Different.
Guaranteed. Liquid is the same. Liquid is the same. But what is different?
Height.
Height.
Or levels are different. Levels are. When the
Sir.
level become different, what can you tell about hydrostatic pressure? It's also what? Same or different?
Different.
Different. Tell me out of A, B, C, which one has the highest hydrostatic pressure?
A.
A.
Then B, then C.
A.
Second highest?
B.
Last one. At A, hydrostatic pressure at A is greater than, B is greater than,
C.
that is how the order goes. Correct? In the swimming pool, you go very deep. Squeezing is more. You're on the surface. Squeezing is less. You go very deep, squeezing is more. You go on the surface, squeezing is less. Same liquid, different level, hydrostatic pressure is. There you go. Hydrostatic pressure in the same liquid at different level is different. Underline or highlight it. Nearby that write down hydrostatic pressure at A is greater than, B is greater than C. A is greater than, B is greater than C. We can grow it. Or a same plastic bottle. You put holes at different levels. Holes at different levels. A, B. From all of them, water will spray out. In which one water will spray out to a longer distance?
A.
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 Point A.
From A, distance is very long. B, average. C, being very important. Why A goes to a longer distance? Because speed of the water
Pressure.
coming is very high. Why the speed is high? Pressure is
High.
Pressure is high.
here. Speed is low. Pressure is low. A constant also. That is given there.
Time.
But put holes at different levels. Will what? You'll observe water is sprayed out to different levels. You'll observe that the speed of the stream of water coming from lower hole is greater. Lower hole is greater than the speed of water coming from upper hole. Water exiting a hole has a higher speed when the pressure near that hole is. Therefore, it can be concluded that pressure in liquid increases with the depth of the liquid. Finally, I'll take two different liquids. Water, coconut oil. Different liquids. Levels are same. Nothing can answer me. Different liquid levels are same. What can you tell about hydrostatic pressure?
Different.
Different. Not equal.
Different. Levels are same. Yes.
Different liquid
Same.
for the same.
It is different.
Level is different. Same level is
The
different.
density is different.
Density rho 1, density rho 2. When density differs, the hydrostatic pressure will differ. So different liquids, same level, still hydrostatic pressure is different.
Different.
Different liquid, same
Level.
hydrostatic pressure is what? Different.
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 The basics is this. If level and the liquid are same, hydrostatic pressure is same. If level and the liquid are same, hydrostatic pressure is same. If at least one of them is different, hydrostatic pressure is different. If at least one of them is different, hydrostatic pressure is all two both level and the liquid should be same for the hydrostatic pressure. If at least one is different, hydrostatic pressure. Any doubts?
No, sir.
No,
All clear?
Sir, like instead of the same level, can we use the term the same depth?
Yeah, same level means the same thing. All great. YouTube side, that's my phone. Where did I put my phone?
I to get.
Yeah. YouTube people, one person has commented science class, no, math class, yes. Yeah, then where green color part. It's me. Today almost went like a math class. That's how it is the first part is like. You know, in 2 days now, today half of the day is gone. 2 days are there. Maybe it's considered as holiday. You don't need to take it as holiday. Right? You can finish off one full lesson. You don't need to wait until I finish this lesson. Actually, you can finish off this lesson now. What is given is transmission of pressure through liquids. You can start reading it. And gases. Tomorrow we'll be doing that. Tomorrow we have the session. Tomorrow same time 9 to 11:30, 11:30, 11:35. We have the same session. We'll be continuing from transmission of pressure through liquid. Pascal principle will come. Pressure in gases, atmospheric pressure part is coming. Big calculation part will come. And hopefully flotation as well. Archimedes principle part. So before I do, you can do this lesson. So don't wait until a correct time comes now. Don't just sit and wait today. Most of you, I know after 12:30 today, what you will do is you sleep upside down in the sofa, counting how many times the fan is rotating. Don't get addicted to that type of lifestyle. When there is a holiday, you should get a feeling that you can't just wait. Take something, you start doing something. Right? You can finish off one lesson today. Maybe not science, whatever the lesson you like, whatever subject you like. At least start from there. I know you are a grade 10, you have time. No, you don't have time. Already 2 terms are fully posed. Here my time is coming. So don't wait until now. Whatever you don't know from the first 2 term, cover it. Hurry. I'll meet you all back again tomorrow in the same time. If there are any grade 11 tonight, we have the power and energy session. Tonight at 7 to 9, we have the power and energy session. So grade 11 can come for the power and energy session. Grade 10s you can join tomorrow again 9 to 11. Until then, keep working hard.
Thank you, sir.
God bless.
Thank you.
Thank you,
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you, sir.
Assalamu alaikum.
Thank you, sir. Bye, sir.
Thank you.